Yeah, I'm here today at MDL Marinas. I'm representing Furyan Marine Technology, and we think it's very important to work with MDL, with the future of clean marine, and we want to promote our technology and support MDL, with the Furyan technology, and try and work in partnership with MDL. I was chief designer at Lola Cars, chief designer at Penske. I did the Ferrari A1 car, did the first Epsilon LMP1 car, worked for Spiker in Holland, just all over the place. I'm actually, very interested in sailing, and with the COVID that came along, our consultancy business in motorsport kind of wound down a little bit. So we just looked at, what other projects were out there and quite interesting, to keep some of the designers going. And I have a new Grandeza 34, and we've looked at boat shows, we've looked at what is out there, electric boat-wise, and the question was, for myself, would I take my family out on one of these electric boats out to sea, doing the same sort of journeys that we do at a weekend? And my answer is no, you wouldn't. So we then used my boat as a data acquisition. We looked at the energy requirements of my boat, using the diesel. We converted the diesel power consumption and fuel consumption and converted that to kilowatts, and then looked at how much battery capacity would we need in a boat of this size to do these type of journeys. And we thought, yeah, this is actually possible to do. And that's where we started actually then looking at the overall concept of an electric boat. But the main issue still was what happens, with range anxiety. What happens at sea when you run out of power? And the answer to that was a range extender. But, with the motor industry changing so much, range extenders are really out of fashion. So we actually then had to look at basically designing our own range extender and incorporating that into the power requirements that we needed, for the the hybrid boat. No, because this just didn't start, with this actual concept. The amount of concepts that we actually looked at initially, and looking for different range extenders. I mean, at one point we were very close to using micro turbo range extenders. Same technology that's used in a Formula One car, where you actually use the turbine to generate electricity with a catalyst that basically you inject fuel into, it expands, it drives a turbine, that drives a generator. And we were very close to using 2 of these 35 kilowatt micro turbine generators, but there was so much R&D to do to actually get them into production, and we didn't even know whether they were going to be reliable or not. And basically we were left with a big problem of, what are we going to do? We talked to Marla about their range extender, but there's no requirement for them in the automotive industry now. So we had to look and think, okay, what are we going to do? And we made the decision we needed a very small, powerful engine. And we linked up with a company who do very small, compact rotary engines, and we linked that into an axial flux generator, and then put that on the front of what we call our motor cascade system. And we developed our own range extender, which is 70 to 90 kilowatts. Well, I think we've got, first of all, we're going to talk about, it's environmental, first of all. And the other thing is as well, the running costs, of electric over diesel. Very little maintenance, you know, for an electric motor, and obviously having to pay Volvo for servicing a big diesel engine on my own boat, I know what the costs are. So, you know, minimum cost there, and just the fuel economy and CO2 and NOx emissions. We can save, you know, roundabout, even with the combined range extender, you know, 60% on emissions, and full electric 100% on the emissions. And the beauty about electric motors as well, you've got the massive torque, very similar to a diesel, but instantaneous torque of the electric motor. So its response to throttle and on plane is very significantly quicker than any diesel or petrol. We have to be very careful here because, you know, boats are very expensive and clean technology is very expensive. You know, when you look at what an EV car costs, you're paying over 40% more than a normal conventional IC car. So, but if we'd have taken that philosophy, we'd have outpriced ourselves way out of the market. So we took some boats that we thought were a similar specification and looked at the price point of those boats, and we targeted our boat to match those. But obviously, you know, we've got 40% increase just on the battery and hybrid system. So we had to look at other ways. How do we bring the cost down? And the way that we've done that, I mean, we're using our motorsport and automotive background in the way, you know, that we're actually manufacturing the boats. You know, our molding techniques are the way that we do net edging moldings. We don't do any trimming. You know, everything just basically comes out of the mold and fits together. And we've got to reduce, you know, our labor costs. And the boat, you know, being made out of a flax pre-preg, you know, we're not spraying glass fiber, we're not doing resin infusion, we're using a heated mold concept to heat the pre-preg, and we basically keep our labor costs down. And, you know, we've really tried to match, you know, the costs of the Windy Chanel and the Princess R35. And that's our sort of target market, it's the price point. Yeah, so basically we started off looking at, you know, the powertrain, and it's not just a matter of, you know, replacing an engine with an electric motor. We looked at what the power requirements, and we spent a lot of time mapping prop torque and how we could map the electric motors so that they basically match the prop torque. So if you look at a diesel engine and you look at the amount of energy that it uses compared with what it actually needs to drive the prop, you can waste a huge amount of energy. You know, when you actually look at the curve of the prop and the torque curve of the diesel engine. So with an electric boat, you know, it's not like a diesel where you just pour fuel into it, go and, you know, add a few hundred litres of diesel. With an electric boat, you've got a definitive amount of power. And what we wanted to concentrate on was energy management. And that's why, yes, you know, we have 530 horsepower, but we do not use it, you know, because we need to be able to use the electric motors efficiently, and we limit the speed to 38 knots. Because a duty cycle of a boat is very different to a duty cycle of a road car. You know, you're on and off the throttle, you're braking, you're regenning, you know, with an electric car. Now, you can't do that with a boat. You know, you set out, you know, and then basically you put the throttle on, and you're basically, then the boat is running constant. You know, so you have to be very careful, you know, of the electric motors, the cooling of the batteries. So what we did is we went way over capacity, you know, with the motors, and just looked at how do you match the energy requirement of the boat. Well, basically our philosophy is looking at cradle to grave, you know, when we hear, you know, net emissions, you know, the world doesn't see net, it sees gross emissions. And so what we look at is, you know, all the materials, everything that's used in the manufacture of the boat. So we look at the energy requirements in manufacturing the materials. And that's why we chose, you know, this pre-preg flax material. It's a naturally grown material. It's woven, and then we pre-preg it with a bio-resin system. We are producing different layups, different resin systems, and basically putting the core material in and doing a whole construction, but in a panel, and then we submerge it in the water. And we basically look for, you know, the water ingression into those panels. And over each month, we pull the panels out, we will weigh them, we'll dissect them to see whether we've got osmosis, see if we've got any porosity into the fibers. But at the moment, we see no ingression into the materials, and we're using no protection, only the actual pre-preg resin that we've actually impregnated into the materials.